All right, good evening, everyone. Thank you so much for your patience and just attending tonight's event here. Hope you managed to get some of the catering. Don't worry, we have more on the way, so that'll be here hopefully between the two topics, and we'll allow a break time for everyone to enjoy some more. So without further ado, I'll begin tonight's event. So a very warm welcome to all of you. Thank you for joining us tonight at our 8th Kubernetes Australia Meetup here at Microsoft on the November the 9th tonight. Before I begin, I'd just like to quickly make an acknowledgement of country. On behalf of Kubernetes Australia, we respectively acknowledge the traditional land on which we are gathered tonight, and pay our respects to elders past, present, and emerging. So here is our agenda for what we have lined up tonight. First of all, myself will be going through some of the introductions, and we have two exciting topics lined up. So the first one is Securing Kubernetes by Lasith, from Tuesday, and that will be followed by Building Trust Brick by Brick, some of the Microsoft speakers, Dasith, Juan, and Jason. And this will be followed by, we have an exciting quiz lined up in which we have a chance to learn some of the amazing slides which are just on the table to your left, and also sponsored by Tuesday. And that will be followed by a feedback form, and if time permits, we will have open mic and then a group photo just to celebrate another successful meetup. So if you haven't seen already, K8SUG is on LinkedIn. Feel free to check us out by the QR code here, and where you will see all the updates on our upcoming events, not only for Australia, but also Singapore, Canada, and many of our partner events. In addition, Twitter is just another platform on which we are actively posting updates, and we invite everyone to join our growing network. Now, on behalf of the team here, I'd just like to state our mission as K8SUG. We are very passionate about Kubernetes technologies. Our mission is to accelerate Kubernetes adoption, and we are constantly trying to learn from each other to share the best practices. So we're very proud to have just launched over a year now and have such a growing community. Thank you very much to our long-term sponsors listed here from JFrog, CloudCasa by Catalog, Google Cloud, and of course, the official Cloud Native Computing Foundation. And of course, thank you for our event sponsors, especially to Microsoft tonight and Tuesday as well for the swags and speakers and the catering. So here is just a quick introduction about our co-organizers. Myself, on the right, I'm Louisa. I'm currently studying Bachelor of Commerce Computer Science at Monash. And our founder is Young Han, who is not able to join us tonight because he's actually all the way in Chicago attending the KubeCon North America event. So that is the official event by CNCF hosted across continents around the world. And he is a CloudCasa Global Ambassador and created this network in order to help share just learning. And we've currently expanded to 3 countries and continents, and hopefully more to come. And a very big thank you to our organizers. You can see some of them standing up and waiting. So they generously give up their time and efforts from some of them the very first event which they were just like one of you, just an attendee as well. So this couldn't be done without them. So thank you all, Mark, Susan, Harrison, Christina, Tiago, and Yen, all of them present tonight for helping us. And hopefully we'll see you more when you join our team. And as I mentioned, we welcome more volunteers, sponsors, and speakers. So if you're interested and at time, please follow any of these links or come have a chat to any of us. Now, just to wrap up, here are some upcoming events that we have. So If you're not able to join them in person, we also have the live stream and the recording that will be uploaded just as today's will be. So on 16th November, the Singapore one will be hosted at Google, followed by our Australian event on 5th of December at Red Hat, a long-term partner. And in Canada, we have an event at AWS on the 14th. So this is just an exciting announcement. And the last thing before we go on to the topic is that we are very excited and proud to be announcing the Kubernetes workshop, which is just today. We're taking an expression of interest, but they have been designed and will be delivered to you free of charge exclusively for our K8SUG members at first. But we'll be covering from the very beginning Kubernetes basics, this term Kubernetes 101, because I understand many participants, myself included, have a very vague or are completely new to the entire concept of Kubernetes, let alone the advanced topics such as administration and security. So this is just an opportunity tonight. We want to present to you the rough outline of what will be occurring, especially from the beginning, where we have the very basic introduction terminologies, and these will be hopefully delivered online and on demand in time. So towards the end, during our feedback, we'd love it if you could express your interest, if any, and what you would like to see in these upcoming workshops. Of course, they'll be delivered by our very own founder and many of our volunteers themselves. So without further ado, I'll present the topic and speakers for tonight. So as mentioned, first up from Tuesday, we have Lasith to talk about his topic nominated, and I would now hand over to him for his speech. Thank you very much.
All right. Good. Thank you. All right. Well, I'm here for the first time, so I've been a really long day. It's great to be here. Thanks, Kubernetes user group Australia for having us here. This first time we have presenting events like this. So my name is Lasith Haturusinha, part of the SUSA team, SUSA Solution Architect, and based in Melbourne, works with the Southern Region team. Got my, Santiago in the back as the field market managing. So, organize everything today, just get these things ready. I want to keep it simple. I didn't want to go into more product discussion, but I thought, okay, look, when asked what are we going to do? Do we want to go on a learning curve or what are we going to do? So we got this a sacred cloud. And so it's not something we can find. And I thought, okay, well, just going to work with this with you, with everyone. Just listen to us and listen to me and talk about it. But I'll try not to be too product based or on a product page. Okay. Right. This is a survey done in last year around the from CNCF on some of the challenges, as adopters and users of Kubernetes. And security places as a particular challenge for everyone. Right? Even we spoke about some of these one-on-one courses. Security was one of the topics that people want to learn about. Because it's a new thing. Everyone knows about Kubernetes, everyone has done something around Kubernetes, but once you bring your workloads into production environments, you get experience in some areas. sort of attacks that goes around and all that, right? And this survey pretty much talks about that security is number one challenge, and also lack of training. And I was like, okay, this is a basically, brought me into this session perfectly. So the top challenge, security. You all understand when we are running workloads on in one enterprise level. This is another survey done by VMware to find the university's population, but again, when as part of the challenges of exploring Kubernetes, different challenges are represented on the slide. But security again is one challenge that people face. It's so much that they need to focus on and understand, because that's an environment we're trying to understand. People in various organizations, various products being launched, the different ways of managing these security threats in the Kubernetes space, right? So again, we understand Kubernetes security is one challenge. And even if an organization wants to choose the right container strategy, a cloud-native strategy, can be different reasons, but there's one part that they have to focus on, and that's security. Right? So what industries are we talking about? So every industry. My personal interaction with customers basically tells me that it's not just one industry. Everyone is trying to build something, maybe start with a proof of concept, or they've already started as an internal project on building Kubernetes, probably application of thinking of moving from the whole monolithic approach to how we approach, or maybe building something on the cloud, on-prem, wherever it is, or maybe they by their own little team doing this little testing and building a cloud-native approach. But each and every industry does that. And each and every industry needs to understand that security principle. Whenever we have a conversation with a customer or somebody, we tend to realize, okay, they have an understanding, they know what they want to do, they've started their journey, but they pay a little or less attention on security. And that's why all these surveys that I put on the previous slides tells you security plays a pretty cool. Right? Even though this whole journey on Kubernetes has been for a long time, people pay less attention on security. Right? Challenges. Containers are increasing, as I said. The popularity is increasing. Mentioned, everyone starts doing something around Kubernetes on containers. So there's more potential, more attractiveness for attackers to exploit that. Traditional tools will not work on a Kubernetes environment or cloud-native environment, right? And then you focus on container automation. You also want to make sure that you automate the security as well. Right? So these are different challenges that organization faces around Kubernetes. And hence the reason we want to talk about SUSE block security and see how we can help as an organization to address these challenges. Briefly at either. Right. So SUSE new vector. At the start, I said, we understand the importance of security as a company, as an organization. We have made sure that from the OS level, SUSE Linux, to Kubernetes management, at each and every level, we understand the importance of security. Right? So we acquired a company called NewVector. This was a closed company, and after the acquisition, we made it open source. So anyone who wants to try it out, it's available open. It's everything, download, run it. Same way we do with franchise. NewVector is a complete full lifecycle container management tool. So one part of choose a new vector is to have that full lifecycle basically from pipeline production, hence topic, right? You safely integrate it from pipeline production. New vector allows you to do the bill scanning, so probably so the same things will be discussed in the next slide as well. Right? So we need to do new vector allows you to do the bill scanning, allows you to do the register scanning, and also some of the compliance management as part of the solution, part of the tool. Apart from that, once you build your containers, once you deploy those containers and at the runtime, it allows you to do the runtime protection as well. So it covers 2 layers, right? And then once it starts doing runtime protection and understand the behavior and everything, you can probably deploy your new vector with a certain environment, a certain cluster, and then you surround it. Say, okay, this is the perfect security policy that we want. You know, expose that, right? So you can have security policy as a tool, and you can also use that for automation as well. Okay, so with the previous slides, okay, as I mentioned, 2 major components. Supply chain security, which covers the vulnerability, compliance, and mission control, and the runtime security, which is a runtime, threat-based, and zero trust control. Let's look at what covers on the supply chain security. So a developer builds the code, and they commit the code, and then they push it through certain CI/CD tools to a public or private registry, and then in some environment pulls down and use that image and builds your workload containers. Right? So new vector can play an each and every section. Basically, new vector has plugins for various CI/CD tools like Jenkins and GitLab. And once it's been placed, it will do the scanning, it will do the pass and fail, right? As part of the build. And then once it's done, it will allow you to push it to private registry or public registry. And then even on the public or private registry, you'll start doing the scanning, So this will be more explaining in next few slides. Does it make sense? Sorry, I'll be talking a lot of mind, to see some sort of interaction as well. But yeah, it's all good. Everyone can hear, make sense what I've been talking about. Yeah. Okay, right. Okay, good. Conscious of time as well. So, and then I spoke about supply chain management, right? Compliance scanning. These are some of those compliances that we always come from, right? So, certain industries, these are very, very important. I believe it should be important for each and every industry, but certain industries are very important to make sure that they sort of make sure that these are compliant as well. So benchmarking. So new vector allows you to do the compliance scanning or around these compliances, right? Which helps you to make sure that your environment, whatever that you're running, is compliant, and allows you to build and create reports on that, which helps the CIS team as well, information security team as well. All right, so this is the one that I've said I'll probably talk about a little later. So I'm going to be standing here, sorry, to make sure that I'll be clicking this slide. All right, again. So 4 supply chains layers, right? So you got to develop an engineer who has a development environment, and what he's going to do is he'll build an image, right? So there will be a certain new vector will do the pipeline and compliance scanning at the build stage, and once it's done, they will push that image to the registry, and at the registry, it will do the registry scan. This is continuous scan that it will run, right? Because you need to sort of set up, okay, which registries I want to scan, right? It will not be able to scan the registries. So you need to sort of, say, I want these registries to be scanned. So then you have to run the scan. I do this. So once that's done, different clusters or different environments will require to pull these images, right? So once you pull these images, right, new vector can integrate with your own admission controls, or new vector will has a way of doing admission control within itself. So admission controlling at which basically tells you who is allowed to run these images. Let's say you pull an image, you don't want that image to run, let's say, in production. You want to make sure that it runs on the unstable environment for the time being, right? So you can allow using the emission control as to where it should run, you get to place that rule as well. And once, let's say it's all good, pull the image, I'm ready to run, build some workloads and run those on those clusters. I want to have some security in place at the runtime. And that's layer 4, right? So the runtime scanning again against vulnerabilities and runtime scanning. So this is what I said for the supply chain security. Right. So what covers the supply chain security? And the next part is the runtime security. Yeah, it does sound like a black practice, but I'm trying to, this is a solution that we have. It's open source, and reason why we talk about it here at a user tool, right? So you can play around and you can feel what it is, and you can also, as part of it. So there's always been open source company allowing you guys to, sort of use it, say what it is, contribute back. That's part of the open source DNA. Okay, moving on. Runtime security. Okay, so as part of runtime security, you can do thread-based control or zero trust control. These are the two segmentations comes under runtime security. So thread-based controls, you can do a scanning based on CVEs. You can go at application network effects or based on OWASP content or mission critical. Different ways of doing the thread-based scanning. When it comes to zero trust control, NuVector allows you to do the scanning at process level, file level, and network level. And it will also do the automated learning to understand what's going on in your network in terms of the process, because you write a code and you just deploy it and you make sure that it should run according to the code. So NuVector will make sure that if everything works according to the code, we as human beings, we probably have done something and we allow it to run. And then realize it's exploited when something is exploited, you start realizing, okay, this is what it's working. So it saves time trying to understand what's going on in the environment in faster. So as part of the runtime behavior, we all understand there's so much traffic moving from east to west. And it's huge number, right? When actually deployed in production environment. NuVector allows you to sort of predict not just the east west traffic, but also north south. So again, a feature that brings as part of the NuVector solution. The runtime behavioral inspection. And also, I'll include these last few slides. Is the automated behavior of the runtime protection. Now, when you deploy in a cluster and you want to run certain workloads, you're bringing down all the or the scripts and everything ready to run, and then just do the deployments. Once it's been deployed, the applications will behave in a certain way. Right? By default, NuVector will put that cluster into discovery mode, learning what's happening in that environment, trying to understand what's going on, what's being allowed, how those processes should work, how those networks should work, right? What files are being used, right? It starts learning, right? Once you're ready, you can bring that cluster through NuVector. You can bring that cluster into the monitoring. It is allowing you to understand and alert and enormous application behavior. We run these codes, we deploy them, we want to deploy them, and start using these, deploy those clusters in a certain way. We won't have the capabilities with each and every behavior. That's why you need to. So in the monitor mode, we will be able to start monitoring. This is alerting you, okay, these are like shouldn't be behaving the way it should be as per the code. Right? Once you might probably need to do some changes, manual changes in code. All right, okay, I need to allow this code, I need to allow this file access, whatever, right? You have to make some changes in that cluster into those workloads. Once those changes are made and you're ready to sort of agreed on the behavior, you can bring that cluster into a protect mode, which basically if someone tries to do something, right? Maybe an attack or maybe trying to, access to a certain service, right? You will deny that at a runtime. So this is a feature that we see is really useful for anybody who's using and applying to the alternative workloads and also have a certain level of protection. Not just the vulnerability and compliance scan, right? But at the runtime. Right. So wanted to keep simple. As I said, I try not to be like a usual solution architect. Trying to sell something, no. But there are two features that comes with the new web. And this will be a great place for you all to understand, learn something, right? Okay, sorry, I haven't really heard about the product actually. Okay, let me download because this is useful. In the true sense of open source, right? You download something, work in your that environment, whatever environment you want, right? So why new vector? This is where marketing comes in. It's faster to that. The source of truth is the network. Right? Easy to deploy, you can automate, and can run on any Kubernetes, any native Kubernetes, as long as there's CNCs. So we're not restricting ourselves to say, oh, you should run on our Kubernetes, or you can't run it on cloud, anywhere. Right? So anywhere. And supports the other environment, and you can actually scale to most clusters. And the unique capabilities in UX is that automating your security policy, right? Understand and you build your security as a support, and then use it to deploy on other environments as well. Different things like zero trust protection, DDoS prevention. Look, it's great to try and see what we can do, how you can use it in your environment. And it's in your CSV pipeline. It's hard at that. So yeah, this is a brief introduction to the tools that series of was required. A great tool because closed, you need to open, use it, right? And one to share stories that security is a crucial or key factor for any environment, any industry. Let's talk about this. That's it. Thank you so much. Yeah. At the moment, it's the last. One more question. Yeah, sure. Yeah. And provide report from yeah, it is not from yeah. So based on our experience in some of that users, this who uses the new vector. Yeah. So because these are standard compliances that we need for that whenever you do the compliance scan, you can get a report that it's compliant or not, should be. So this is my understanding. We'll have have an expert really do this in detail from our team. My understanding is what you will have a certain build time activity, right? You do the building and you do a scanning and you realize there's certain things that you want to change. And once you start fixing those, right, then it will be a it's the first time that we do it, and that's why if we can integrate with your CLA pipeline and we do the parts that fail to the new expenses. So you will have a good time at the beginning. But as time goes by, it will be I don't know that concept. It's sort of the process. Yeah. We won't go from the field to problem. Yeah.
So regarding the analog,
yeah.
The behavior, application behavior monitoring, right? What does it actually monitor? Are those signals defined by the user?
Yeah, so based on the code, based on the network, and let's say when you build and when you finalize, let's say I want my cluster to be, I want my deployments to work in this particular behavior. Let's say you put it into production mode, then it will always reset. For example, let's say you're not allowing the pods to have access, right? You won't allow. It won't allow. When you put this at the start, when it's on this one, you can access to the pods, you can do everything you want, but and when it's ready, to give non-production level, propose it. I don't want anyone to have access to these pods. Once it's been placed, when it's been approved, you will, as I said, you will push that into the protection mode. It won't allow. So it's all based on the policies you set, and based on the PHP or control variable. Based on all this information, you will be there following that. So do what I call e-packet inspection.
Like does it have
Video not at the moment, but it's something that we're trying to bring into our experience. But yeah.
like how does it get access to it? If I'm running in this video, how does it get access?
So basically you deploy your vector into that cluster. Yeah, it's on. Yeah, it's on top. It's more like a but it's deployed on that cluster. Let's say you've got multiple clusters and you won't have new vector just on the production, you want to deploy new vector on the production. The same way you do Internet with Prometheus in the part, right? You deploy Prometheus onto a certain cluster.
Doesn't have access to it from I just started understanding that. You said one of this
From not start. Yeah.
But in that practice, that's pretty hard. Something to find for the five star and everything. Something to in practice.
I won't have detail, but I know it to be done to, but I think you want probably can get more information on how actually it's being done on an actual technical level. Yeah. Yeah. Yeah.
First one, some said is the user affected and due to the development of that, but they use the effective
Yeah. So this is how I would think how we will begin on based on that, right? So once it's been built, once you got this, a cluster, right? And as I said, you can bring your cluster in this problem. I'm trying to understand because developers will develop, they won't be really caring about what's going to be blocked and all that, right? Because it's not their way. So more or less set up or whoever who wants to make sure that it's more secure and has that partner performance level of security. They'll put it in a discover mode and understand what's being allowed and what's being blocked, right? And based on that sort of report, you can actually say, okay, yes, it needs to be access to database faster do. Once it's in place, then you can change that protection mode into it. It's not just down format. That makes sense. So it's a manual thing that you will require. Just by default, it will be in this color. You will start learning what the database are. It will start and understanding what it should be, how it should be behaving. And then only you will probably bring those changes. Let's say I want to allow certain things to be kept in certain way. And then only you will put them in the position mode for marketing. Yeah. 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 So if it's something to be allowed, right? So it's something that needs to be allowed, then you would probably place that in policy. But if not, it's not. All right, thank you. All right, I think it's time up. Thank you.
Thank you. Thank you so much for the question so far. If you have anything else, please say.
Yeah,
But we now have the second round of catering. So if anyone else is interested in some more food, there are some food available, and with short break, we hope to resume our second topic at 7. Testing. Testing the audio document by Zoom. Perfect.
Did you find it?
Yeah, he's still people in the toilet, so he has to open the door. I told him to find someone else to.
Unfortunately, it's very real.
Yeah. At least his part is at the end. So yeah. Yeah, maybe in the interest of time.
Thank you, everyone. Thank you. So we'd just like to resume the meetup tonight. So we've now been moving on to our second topic presented by the trio from Microsoft. So I've got with me here, Dasith, Juan, and Jason returning very soon. So we're now like to begin the second topic of the night. Hopefully you enjoyed catering part 2. Okay, so now I've got everyone back and comfortable. Let's move on to the second topic, and that is through house brick by brick, presented by the Microsoft trio here. Thank you very much.
Thank you. So welcome to a talk, Building Trust Brick by Brick. In this talk, we'll look at the modern software supply chain and how to secure it. We did a shorter version of this talk at the recently concluded Happy Days conference. This is a extended cut of that with a bit more details and samples. Oops. Doesn't look like it's
Right or left, right or left. You broke it.
coffee right now. So my name's Lasith. We've got Jason and Juan. We're from the Industry Solutions Engineering side of Microsoft. Our dev crew works mainly with defense and government, and as a result, mostly we work with very small, very technically risky POC and MBE type projects. Over the past probably 12 to 16 months, we've been looking at supply chain security and security Kubernetes workloads running on both edge and on the cloud. So this talk shares some of the journey that we've gone through and some of our learnings and scars. The agenda for today is to give you a brief introduction of supply chain threats, because it's important to have that view of what a threat is and how to mitigate or reduce the risk of that threat. We'll look at the producer side of things. So this is people, software development teams, producing artifacts like container images. Then there's the way to store those software artifacts, not just container images, but the evidence that goes with it, like software bill of materials, even things like your Helm charts. There's now a modern way of storing everything together. We'll talk about that. Then on the consumer side of things, this is, let's say, ops people consuming the container artifacts that the software development team produces, how to run them securely, consume them securely. And at the end, if you have time, we'll take some questions as well. To start off, how does a software supply chain contrast with traditional supply chains? In a traditional sense, you've got a material that goes through your factory, gets delivered to your shop front, which gets used by users. In the software side, you use your open source dependencies or internal dependencies to build through build process, and we use a network to put or host them in some sort of repository, which gets deployed to a environment from there. And this is the supply chain. When we refer to supply chain, this is what we mean in the software context. Now let's look at some of the threats and why this is a hot topic. As you would have noticed, both the talks today are somewhat regarding the supply chain side of things. So no surprise, everyone, it looks like, is using open source to build stuff today. And I can't think of any team who's not doing that unless it's a very specific use case, which means any vulnerability in your software open source dependencies is going to be a vulnerability that you have to care about. And this is the environment in which most of these tools we're going to discuss today come to our rescue. This chart, this graph, it's the Salsa software lifecycle. I can't remember the exact thing. Salsa.dev. That's their vision of the threat overview for the consumer side. So straight from having unauthorized changes submitted to your code based on, and all the way on the right-hand side for the consumer using a compromised package. Every step in between has a threat vector. And I won't go into details of each of them, but some of the tools and the use cases that we're going to discuss, you'll be able to relate to this. The links are at the end as well. We'll share the slide deck after on social media and LinkedIn and stuff. So that's on the producer side though. On the consumer side, the main threat is impersonation. So think about in a classical scenario, like if you really wanted to make sure that the artifact that you're getting is the artifact that the producer produced, you'd have to go physically meet the producer, but we don't do that anymore. Just because something comes from, let's say, a trusted source let's say, FTP server of, I don't know whether that's a thing anymore, container registry that's hosted by a trusted source, doesn't mean the artifact that comes from there can be trusted. They're two separate things. And we're going to show you how you can independently verify that the artifact came from the entity you think it came from using cryptographic verification. This is the big scenario we're going to cover today. We got the producer and consumer side from left to right. We've got the steps on the left-hand side, which go through standard steps to build something, like a container image on the that's on the producer side. On the consumer side, what's involved in ingesting and running it through the several processes to get that deployed in a environment and continuously monitor that. And we'll hand over to Juan to go through it. But if this is too complicated just by looking at it, don't worry, we'll go one step at a time. Juan, all yours.
Can you go there? Probably.
Yeah.
So, hi everyone, my name is Juan F S Burckhardt. I'm Latin American, that explains the long name. You can call me Juan Burckhardt. And what I will be talking today is on the left side of the supply chain. So imagine in the supply chain that Das presented before, you can imagine the left side is your materials. If you don't know where the material came from, or you are not secure about your materials, it's really difficult to do any security after that, right? So for doing that, what I will do is I will mention some well-known hacks or security impacts that occurred before, and I'll give a set of tools or best practices that can help mitigating these actions, right? So the first one is this one from Stephen Lasith. He mentioned in one tweet, hey, I find that 35,000 repositories got infected as somebody was impersonating and making a commit. It was a big statement. When they started to research, it was not 35,000 repositories, way less. But what was happening was some impersonation, not only on the developer level, but also on the repository level. Imagine a spam email. They start to have like, this is the real repository, dash verified. So people started to go to this repository, and when they started to see commits being done by well-known developers of the environment, they said, this is the real repository. What happened in there is they started to go after your crypto repository, after your crypto wallets, right? So if you go to the next slide, thanks. So one way that appeared in that moment, and they start saying how we can validate this, it's a really simple thing that is signing your commits. This should be a basic thing that you do in every repository. Signing a commit is as simple as the same way that you give your name in the git config. Please sign your commits in GitHub, GitLab, any open source. You will see the option in which you have, don't let commits that are not verified get into main branch. That way you will be one step more secure than just accepting any commit. It just gives a cryptographic validation of what is in the commit. Next one. Going to the next one. Well, this is the event stream. This was a little bit cool. So the developer owner of this repository was taking, he was maintaining the repo by himself, and in some moment he just didn't have enough time to keep doing it. And a bad actor came and said, hey mate, I can help you maintain the repository. There are some issues in there. If you give me access, I will maintain the package, and I will have the package in NPM. And what happened there is they gave access to the bad actor. The bad actor started to add some repositories in, fix some issues, but then again went after a crypto wallet. And when people started to do the NPM package install, they started to install the vulnerability, right? And what happened after that was like the guy gave the keys. He didn't have access to get it back, right? So how you can do something, or how will you prevent or mitigate the impact of these kind of things is as simple as running a SAST or a Dast in your pipeline. It is just code smell. It will force you to have pin your versions, right? It's something that is really basic, it's something that is really necessary, and everybody should be doing it. If you commit your code and you have a version that is not pinned,
your commit is not static. And that's not what we want. We want to have a commit that if you rebuild that code, it's going to be the same all the time. Your vulnerabilities are dynamic, your code shouldn't. Right? So again, how you will mitigate that? Just simple does and does using GitHub. Now they have code secret scanning, Copilot, what's the other one? The one that's secure that is looking into the requirements.txt, for example, dependable. So it's really easy to enable, are things that are really basic to configure, and they will save you a lot of pain. The next one is, I don't think I have to explain this one, PRs. If you just have one PR, about actor will go ahead, right? So at least you should have 2 PRs in that. I don't think I have to talk more about this one. If we go to the next one. What is this one? Log4j. Okay, so here we're going to talk about the gist of when you start to see a secure supply chain and it's the generation of this bomb. So this hack was really painful. And the main thing is that you couldn't distinguish if you had the vulnerability when you check into your basic dependencies. It can be a shell dependency. So this bomb, software bill of material, I hope that everybody's creating one when you're building your code. Helps you to create that graph. So if you go to the next slide. So what is the purpose of a bomb? Is to help you with transparency, security, and compliance. Compliance mostly because it is checking all the licensing of the packages inside. Security, as in when it generates the graph, it's really easy for the owner of the code identify where a package is located. And transparency, well, if you have this bomb, you know what is in your code. That's now a law, so you should have it. Here we don't talk a lot about the different type of SBOM, but you can imagine that you can have different generation of SBOM depending on what you generated, right? I think that's on the SBOM. You go to the next one. These are common tools that I'm using. I saw a couple of projects when we asked, hey, are you generating this bomb for your code set or for your container? I heard a couple of times, we will do it later. We will create a story for that, but it's just a command. I think I have an example here. Yeah, like, this is an example using Treaty. You can create this bomb really easy from the file system directly where you're located, or you can create it against a container. This bomb helps you a lot on the security level because now you have a graph of all the dependencies inside your code, inside your product, that can be checked against a vulnerability database, right? Let's go to next. SolarWinds, oh, it was super cool. So what happened in this one was, for the guys in SolarWinds, the package that was getting generated as an update got infiltrated. What happened there? Bad actor got into their network, bad actor got into their CI/CD, into their build agent, and ingested a script. It was really difficult to find, right? What is the idea here? What I'm trying to explain, if you add provenance to your CI/CD, you go to the next one. There are multiple, go to the next one. Sorry, there are multiple ways to create the provenance of your CI/CD. What it does, it gives you a state of your agent while you're building your code. So it wouldn't prevent you from having that pain of the SolarWinds hack, but it will be really easy for you to identify which package was built in that agent. You'll have the state of your agent at the same time that you're creating your package. These are really simple things to introduce. It's something that I reckon should be in any project. There are not things to do later. As I show you, it's really easy. Commit signature is one git config GPG, or you can use your SSH key. SAST and DAST, most of them, they come out of the box. And this bomb, you please create it. And lastly, the provenance. I think that's it from my side. Yeah. Chain articles.
Thanks, John. So Juan described the best practices, some of the best practices when producing a software artifact. But how, now that you produce a software artifact, how do you get it to your consumer? In the old days, we used to store it in an FTP server, like I mentioned. If it's a container image, you put it in a container registry. in certain cases in defense, even USB. So let's see what a modern way of doing that is. So again, to get your mind back to the problem we are trying to solve, we have a producer who's trying to get the consumer to use the artifact in a secure way. And we do this by a mechanism of signing, and to sign, we use a private public key pair. And this is the producer, Lasith Networks, having the private public key pair. We give the public key to the consumer. Then we sign the artifact using the private key. We then don't really have to worry about where the artifact is stored. The artifact can be in the most insecure location. The consumer can still retrieve it and independently verify using the public key that it was produced by the entity that they think it is, that is Lasith Networks. And this is the mechanism that will allow us to ensure provenance. But signatures are not all the same. There's different ways of signatures being used. Like if you run your mind back to like Windows EXEs where there's a signature embedded, it's good because it travels with the, let's say, the EXE. But the problem with that is once the EXE is in a system, before you check whether the signature is valid, if there's a vulnerability in the mechanism which checks that, if there's a memory leak or something, the process of checking the signature can actually load that thing into memory. And there's been threat vectors in that space as well. What if we detach the signature from the actual artifact itself? That way we only need the signature to verify rather than the artifact. But just having the signature by itself is like putting a yellow sticky note in your, I don't know, in something you own. It doesn't really mean anything. What does a signature mean in this context? So the best way to do it is to actually generate a set of claims about the thing that you're claiming. Let's say I'm claiming this artifact was made by me, and I claim this artifact was made on this and this date, and then I sign that statement using my signature. This way the statement is kind of like your attestation about that artifact. And this is the mechanism we'll use the modern mechanism we'll use to ensure that the provenance can be verified. And the tool we use for this is called Notary. And the CLI for this is called Notation CLI. And this is a product that's been in collaboration developed by Microsoft, AWS, and it's a CNCF project, fully open source. It's very easy to start using this today. If you've got a container or OCI artifact, get the digest of that. The reason why we get the digest, it's that way is intentional. You're signing something that you think, you know, that is exactly what you produced. If it's a tag, someone could push something. Meanwhile, you're signing and you might be signing something that someone else produced. So always use the digest. Then you sign it, and then the signature gets attached. It's a separate artifact, but it gets attached to the main artifact. And to verify it, to view it, you just do notation list, and you can see the signature will be attached to the main artifact, and I'll show you the mechanism for attaching shortly. To verify it is as simple. You have this concept called a trust policy. You import the trust policy into notation. The trust policy spec I won't go through here, but it's very detailed. You can get very granular control up to the repo level as well. Then you just do notation verify, and you pass the OCI artifact or the container image name, and it'll give you a thumbs up or thumbs down. This simple mechanism allows you to ensure that the artifact is what you think it is. Now, there's another tool that works in the similar space called Cosign by a company called Sixto. This is an open SSF project, and they work in collaboration with this project called InToto for attestations. They do a very similar thing to notation in allowing you to sign artifacts as well. Their approach is pretty similar. You sign and you give them the key and the image, just like before. Verify, it's the same thing. You pass the public key and the image, and it gives you the thumbs up or down. The attestations is a extended version of it, which uses in-toto attestations. It's like, imagine being able to attach files and sign the file into the main artifact. This is that. I won't go through details, but it's a very simple thing to do. Like if you've got a software bill of material, this is how you would do it. And the other thing that cosign allows you to do is do this thing called keyless signing. The way keyless signing works, and this is what most open source projects do these days, is rather than having a key, they create an ephemeral key, like a 5 or 10 minute key. They sign into a OpenID Connect provider, and then record that action of signing in Sigsto's T-log. And this T-log gives them an ID right at the bottom. And when you're verifying, you can just go look at the T-log and it'll have the details of the key sign, the person who logged in to that OpenID Connect provider. And this allows this is like kind of like a trail, like a transparency log of what happened to that artifact. And for verification, you can pass the identities, the email and the identity provider. Let's say if you have your own identity provider, or use the one that cosign has. So this is a way of doing it without using keys. And in certain cases, this is good enough. And in terms of differences, if you're just looking at it from a signing and verifying perspective, they're similar, but the signature formats are slightly different. Their payload formats are slightly different. Notation is more modern in the sense that it uses the OCI spec or the reference API to have these signatures as attachments. Whereas with cosign, they use a tag-based system, which means if you're looking at your tags in your catalog, you're going to have a lot more tags because it creates new tag names to create the signatures and attestations. Now, I keep saying artifact. Isn't it just a container image? It's complicated. The reason why it's complicated is the OCI spec now allows you to put anything, not just contain images in an artifact register. So if it's OCI 1.1, you can put contain images, you can put any blob, anything. So we can take advantage of this. So this is the OCI 1.1 image spec. So we've got the artifact type as a new field being introduced. In there, you can put the type of the MIME type of the artifact. The media type still remains as image, but the layers now can contain different things according to that MIME type. And the other important thing is this new subject field. This allows you to attach this manifest to another manifest. So this is creating like a tree structure now. And we make use of that because now we have supply chain evidence like software bill of materials, signatures, Helm charts, etc. What we can do is using this tool called ORAS, or it's called OCI Registry Storage. Using this, we can simply attach anything to an OCI artifact or push image things that are not contain images to the registry as well. And this is the tree-like structure that it creates. You've got the main artifact, got the signature for it, you've got a software bill of material and the signature for the software bill of material as well. And now everything's ready to be consumed. We've got a way of securely verifying provenance, and we've got evidence. Let's see what we can do on the consumer side to securely consume that.
Cool. Thank you, Daz. So, consumer side. So let's say, for example, Web Networks created an artifact. I am Acme Rocket, and I want to ingest that artifact and introduce it into my organization. So the steps we want to do is, first we want to ingest it. We want to create a copy of that, and we want to, before we ingest it into our system, we want to check for things like signature. We want to know who, well, we want to verify that the artifact that we're bringing into our system actually came from Web Networks. Because if the signature isn't there, or if it's not valid, then how do we know it came from them? We want to check for provenance. We want to ensure that we know exactly how it was built, what commands were used to build it. We want to know, well, we want to ensure that there's an SBOM because we want to know the dependencies that artifact consumes. And maybe we want to do some other things like virus scanning, so if it's like an exe or something like that. There's a couple cool tools. We already talked about notation and cosign for signature checking and provenance. Open Policy Agent, we'll get into that a little bit, but Open Policy Agent is a nice tool for emission control before deploying into your Kubernetes cluster, and as well as enforcing some policies that you might have to, enforce that, there is a signature, there is provenance, there is SBOMs, all that stuff. You can use Open Policy Agent for that. So for an example, so what we want to do is, we're fine, like it has everything that we need. We want to create a copy of that artifact and we want to bring it into, our internal artifact store. We'll call it artifact store A. This is just so that we have a copy of that, because we want to, when we want to ingest it, when we want to reuse it, we want to pull from our source. We don't want to pull from an external source, because that external source could change. So we want to ensure that the copy that we ingested will always be that copy. Next, we want to deploy into a UAT environment just to ensure that the artifact that we're ingesting actually works and does a pass. Whoops, went a little bit far. If it doesn't pass, do nothing. We don't want to ingest it because it's not fit for purpose. It doesn't work. But if it does pass, then we move it into a separate artifact store. We'll call it artifact store B. This once it's in artifact store B, we're sort of happy that other teams within the organization can reuse it, or even we're happy that we can deploy it into our infrastructure. And for example, for containers, you might want to reuse that container as like a base image for something like that. So if you're going to reuse it in one of your other artifacts or one of your other projects, then you'll go back through step 2 and you'll do UAT testing and everything like that. Cool. So vulnerability scanning. So what do we do with an SBOM? So once we have an SBOM, which as Juan was saying, an SBOM contains all the dependencies that are inside that artifact, which also includes the version number and maybe the licensing and things like that. Scanning it just the once when we ingest it is not enough, because when we scan an artifact, when we bring an artifact into an organization, at that point in time, the known vulnerabilities of that artifact, may be very minimal. But in 5, 6, 7 months down the line, all of a sudden there's a highly severe vulnerability. And if we just scan it the once when we ingest it 6 months ago, then we don't know that that's an issue that's currently inside our organization. So with the SBOMs, you want to continuously check it, maybe X hours, maybe 24 hours, maybe 12 hours, depends on your risk appetite. You want to store the reports, so you want to keep reusing the same report over and over again, because you don't want to keep updating the same SBOM. The SBOM should be static at that point in time that you ingest it. And you want to create alerts and quarantine policies so that when severe vulnerabilities, or at least vulnerabilities that are outside of your risk appetite, is detected, you want to be able to have processes in place to ensure that you're mitigating it, or you're doing something about it, like maybe updating or checking to see if there's a new update to that vulnerability. Some tools, so we already touched on Trivia a little bit. Gripe is a really nice tool for scanning those SBOMs, and it gives you a list of the vulnerabilities and the severity and all that. Microsoft Defender for Cloud is built into Azure. Sneeko, so you can do a lot of the SBOM generating as well as code vulnerability scanning. There's a bunch more. There's this whole open source community is pretty massive. There's a lot of tools available. So just for an example, so you might use Trivia to scan an SBOM. So Trivia SBOM, pass in your SBOM file. If you're using Gripe, just cat your SBOM file and type it into Gripe, and I don't know if everyone can see that, but you see a list of your dependencies down there. You see if it's fixed, it will actually tell you what version that vulnerability was fixed in. You also see the CVE for that vulnerability, as well as the severities. So a lot of them are I can't say the word. Negligible? Yeah, that word. Right. Low or medium, which is fine. It's really up to your risk appetite. So you might have a policy in place that says if it's a medium severity that's too much risk. So in that case, then you'll do something about it. Little meme. I found this on Reddit. I thought it was funny. You know, this should be the last release of the year vulnerability report, actually, because you know, yeah, I thought it was a little bit funny, but obviously you guys don't. Anyway, so protecting the last mile. So this is the mission controller side of things. So what you want to do is like, well, for example, using the Kubernetes example, you want to ensure that only trusted containers are being deployed into your environment. And you want to check to see that, you know, before you deploy a container into your Kubernetes cluster, that there is the severity of those vulnerabilities below the threshold. And if not, then don't deploy. So a couple open source tools that can like help with this. You know, Open Policy Agent, Gatekeeper plus Ratify. This tool is really good for checking that the container that you're deploying is signed, either notation war or cosign. War key vulner. I don't know if I'm saying that right. Apparently I'm not saying it right because every time I say it, someone says, no, it's blah, blah, blah. I'm like, oh, okay, whatever. Key vulner, I think it's key vulner. I'm going to go with key vulner. Here's an example constraint using Ratify. So you specify, you say, it's basically just using Rego. Yeah. Rego, I say Rego because, you know, like, I don't know. Oh, no, yeah, Black Rose, yeah, Rego. Like, anyway, apparently that's not right, but I'm stubborn, so I'm going to keep calling it Rego. But yeah, so this is just setting up your policies within your cluster. And just a quick scenario. So you got a container registry, you want to deploy it. First step, once you do a kubectl apply, you know, -f, pass in your manifest or maybe a Flux deployment. Ratify sits in front. It's a mutating webhook or mission control, mission mutating webhook, I think. Validating webhook, you know, always get confused. Anyway, so that sits in front, it checks to see if it's signed and, you know, anything else that you might have. If it's unsigned, then I just won't do anything. It will just stop right there and it won't deploy. But if it is signed, then it's like, okay, cool, let's go and deploy it. So that's sort of the last mile before you deploy into your cluster. And I think that's it. Yeah, wrapping up. I'll pass it back to Daz.
Thanks, Jason. So what can you do when you go to work tomorrow, next week? Think about generating SBOM for every software artifact that you're doing. It's pretty easy. It's generally a one-liner. You can include that in your CI/CD process pretty easily, like trivially. See how the trivia into that. Generate the provenance. So software bill of materials for provenance. Sign in and test that. If you can't decide on a tool, pick one and ask your IT team to decide later. Start using OCI registry as storage today. So rather than using blob storage or other mechanisms to store multiple things in multiple places, use your container registry. You can store everything there now, including your Helm charts, your container images, your supply chain evidence, anything you can think of, you can store there, and that's scalable. It's proven. The OCI spec covers everything. When you're consuming things, don't assume something's secure or it can be trusted because it comes from a trusted source. Always independently verify that the artifact that you're consuming is the artifact that you think it is. And you can do this by verifying the signature. Have some sort of continuous vulnerability scanning on your internal artifact registries. This could be a paid solution from anyone, or you can hand crank this using open source solutions as well. Admission control, Jason spoke about gatekeep and ratify. Check out ratify. It's an easy way to define the rules that you want for validating the signatures and stuff like that. And then you know that anything that comes in, even if your deployment credentials get leaked, no one can deploy something into that cluster that hasn't been signed by a source you trust. And we're happy to take any questions.
Thank you so much. If you have anything, afterwards, thank you for that second topic. So now we'll just like to move on to the quiz for tonight. So hopefully you're paying attention, and there are some nice slides up for grabs. So the browser Chrome. Stop sharing. Yeah.
Excuse me, can you leave that slide in a moment?
Yeah,
Thank you.
it's here. Later, after this. Thank you, and we'll send the slide out as well. As mentioned, we'll share that. So if you don't get a chance right now, they will be shared. So we'll just move on to the quiz. Okay. So if you'd like to participate, please scan the QR code here, and we do have 7 questions lined up, just 30 seconds tops each. Has everyone managed to log in? Okay, I'll be starting now. So these are a variety of questions, and we'll be starting now. Do we still have to wait? Yeah, wait for set. Wait for set to refresh. About 20 minutes. Yeah, I think that's about everyone. So let's begin with the questions. All right, so there'll be a variety of topics. Seems like the first one is pretty tough. Hopefully the next few will be better, but weeds out the week. So the second question, again, from just our previous topic, which field gets used by OCR spec to represent a relationship to another artifact? Okay. Yeah, we want to check the leaderboard. So first place right now, we got 4 people tied on 2 points. Congratulations to David so far. Third question. So what main role does OPA Gatekeeper play in Kubernetes clusters? Looks like almost 70% got this right. That's great. So halfway mark. Now back to the first topic was which type of application does SUSE New Vector provide security in depth for? Good to see our leaderboard. We still have David going strong. Question number 5. Which of the following security layers are covered by New Vector? Great job to all those who got that. And if not, don't worry, still have 2 more questions left. So true or false, SUSE New Vector supports only on SUSE Rancher. Good to see, almost everyone got that. So our final question, David's still going strong and got Luke followed by Ravi, is what does SUSE New Vector monitor as the source of truth? Okay, and that was the final question. So see the leaderboard, and that was a bit of a change in position, the last one. So we congratulate.
And I have a big leaderboard.
Okay, so we see the total leaderboard. So thank you everyone for playing. Hopefully you got some out of that, something from those questions, or 40, that's a very high participation. So if anyone would like to choose one of our swags, or we give preference to the winners. So we have 9 items in total. So for those who are here and who, okay, so I'd just like to give a round of applause to our top winner for tonight, Luke. Congratulations. So for tonight, we have a selection of swags on the table, or you have the choice of one of these. They come in. So we've got the plushies also sponsored by SUG. They will just be available in 3 different sizes and they will be delivered as mentioned earlier. All right, so let's check out who was the second place. Sorry if I pronounced it wrong, but Ravi, congratulations, and please select your prize. Would you want to come up to select your prize? Perfect scores. And for third place, we have David L. Congratulations, and if you're here, give me a second difference. Shall we go? Keep going, because it's 9 people. So in fourth place, we had Austin. If you'd like to come up and also pick a prize, thank you. Congratulations. He's over there in the pink shirt, pink stripe, yeah. And if he's still present, we have Bo Liu. Thank you for playing and congratulations as well. Round of applause. Keep it going, yes.
Yeah. Saminda.
Yeah. Saminda, and seventh place we have Rory. Congratulations again. And in eighth place we have Shavi.
Yeah.
If you're still present, oh, congratulations. And last but not least, Ashwin for placing 9th. Thank you. Thank you so much, everyone. And if you missed out this time, there is the stickers. Everyone can grab any of those stickers, and hopefully for next meetup, you'll be able to get some. So before we leave, if you don't mind, we have this feedback form for tonight's meetup, and also just a reminder, if you don't mind staying for a quick group photo, we'll get that taken, and then you can do the feedback in your own time. So everyone, if you would like to stay for a group photo, that'd be really appreciated. Just come to the front. Thank you for hosting the Zoom. Stop sharing. Yeah.